Well, moving on with the exponential growth of the internet, computers communicate by allowing each other to write into their systems or networks. With good comes bad, ransom or malware, they take advantage of this communication environment. Why should we and how do we change our thinking and approach to stop these threats? Our keynote speaker, David Ronn, who is the CEO of Zecurity Technology Corporation, is all geared up to answer this question. He will be speaking on the topic, A New Paradigm for Cybersecurity, or How I Learned to Stop Worrying About the Love of Hardware.
Thank you. Well, good afternoon, everyone. I invite you to this private audience, but we're going to have some fun anyway, right? So I'm David Ronn. I'm CEO of Zecurity Technology Corporation. And my topic today is a new, old paradigm for cybersecurity, or how I learned to stop worrying and love the hardware. The issue is we've got our industry has looked at, well, let me start. Thanks to Stanley Kubrick and Dr. Strangelove for my title topic, we'll dive in. Let's talk insanity. The usual definition of insanity that a lot of you have heard and is usually attributed to Albert Einstein, it's actually a quote from Rita Mae Brown, you can Google her, is that insanity is doing the same thing over and over again, but expecting different results. Insanity is doing the same, So let's look at a few fun examples.
Charlie Brown, oh Charlie Brown. This time I'm gonna kick that football clear to the moon.
Yikes! And away! Yikes! And away! Yikes! And away! Then put your little hand in mine. There ain't no hill or mountain we can't climb.
So that's how our industry has been looking at cybersecurity, dealing with penetrations, intrusions from ransomware or malware adversaries in the same way over and over again. If you don't believe me, let's cover a couple facts. IBM in 2023 published its data breach report, and in it, they gave us a few interesting moments. In 2023, the average cost of a data breach in the US was $9.5 million. Now that goes up by another 30% if you're talking about critical infrastructure. The average time to identify and contain a data breach was 277 days. Make no mistake, bad actors are inside your systems. They are wandering around. They are looking at everything you've got, and they are waiting for the right time to strike. These are zero-day threats that you have no clue exist in your network. 50% of attacks left ransomware inoperable, left systems inoperable, or included ransomware. I don't know if any of y'all are from our healthcare conference next door, but they certainly understand. Just recently, Change Healthcare was attacked with ransomware, $22 million they paid. And healthcare payment systems still aren't operable. If you don't think we're still experiencing Groundhog Day, here's a couple other thoughts. A/B Test Institute tells us that 560,000 new pieces of malware are detected every single day. That's 17 million a month. That's more than 1 billion pieces of malware that exist out there. If anybody thinks that we can actually create a list that fully encompasses the malware world, unfortunately, that's just not going to happen. Google tells us that 7% of all websites are infected with malware. That's over 100,000 websites. And in fact, Google finds 50 new websites infected with malware every single week. Surfing is not safe. And finally, Cybercrime Magazine tells us that 4 companies are hit by a ransomware attack every single minute. It's just not very fun out there. What we're doing is not working. Now look, I know there may well be folks in the audience, just like us, who are in the industry. This isn't meant as a dig at anybody. I just think we've got to look at this issue through a very different lens. So how did we get here? Let's go back a couple decades, maybe more than I care to admit. When my co-founder and I were programming, we had mainframes with tens of thousands of users. The systems were secure. You might think they were secure because of the software. They were actually secure because of the hardware. The hardware controlled access and created a controlled environment. It worked. It was secure. That was the old paradigm. So what happened? In the early 1990s, with the internet explosion, the programmers made it so computers talk to each other in a very different way. Ubiquitous computing. A term coined by Mark Weiser. What does it mean? It means continuously connected network devices that are embedded into every facet of our daily lives. Well, that's certainly true. I mean, who goes anywhere without their phone at this point? I think Bill Gates probably undersold it with his famous quote of he expected a computer in every house on earth. It's continuous connectivity. And that means that computers are writing into each other's network. They are actually penetrating with commands into each other's network. That's how the computing world works. Well, that made a lot of advancements. It fueled some wonderful things, but with the good comes bad. Unfortunately, not everybody is good in the world. And the malware developers and the ransomware developers said, hey, here's a great chance for us. We can use this continuous connectivity superhighway the same way everybody else is, because ransomware and malware has to write into your network. They install themselves into your network, and then they propagate. They are using continuous connectivity to infiltrate our networks. Continuous connectivity is the key concept to think about in the context of cybersecurity. There's a great quote that I like from Chris Inglis, our first US National Cyber Director. If I were to score cyber the same way I score soccer, the tally would be 462 to 452 in the first 20 minutes. It's all offense, no defense. The offense, obviously from the malware or ransomware side, is they're poking and prodding. They're finding every hole that is access into our networks. You'd think on the defense side, you'd have things, but the defense actually turns out to be offense also. What are we doing? The industry has taken the view that penetrations are inevitable, and let's try to focus on mitigating or lessening the recovery time and cost. And there's that one word I don't really like very much, inevitable. Why should we as an industry tell our customers that we're going to provide some assurances to protect you, but you're going to have to live with inevitable penetrations?
It always will be. I am inevitable.
I don't think we're living in a Marvel-themed world and Thanos inevitability, so there's got to be a better way to be able to do this. Let's look at the cybersecurity landscape. We'll use the quadrant that everybody seems to like in our industry. You've got design focus and controlled behavior at the top. Over on the right, business focus. At the bottom, code focus, which is identity and algorithm protection. And on the left, you've got technology focus. So we're going to look at each one of these quadrants holistically. I'm not going to try and point out products or services and plot them on the chart. We're going to really talk about the quadrant as a whole. So let's tackle the upper left-hand quadrant. That quadrant is technology focus, design focus, hardware that controls some behavior. It stops some intrusions, maybe, low maintenance and cost. Examples are routers. Now, routers control behavior because they control traffic. Symantec tells us that 75% of all IoT devices that are infected with malware are routers. Routers aren't solving any of the cybersecurity issues. I don't think anyone in this audience believes that this upper left-hand quadrant is a solution. Let's move down to the second one. This is now technology with a code focus, where the concept is to use identity or algorithms to try and protect our systems. We'll stop some intrusions here. There's a higher maintenance and cost. Examples include firewalls, monitor and mitigate software, zero trust, some AI. Let's talk about zero trust for a second, because that's really become a bit of a buzzword in our industry. Professor Virgil Gligor of Scilab at Carnegie Mellon University in 2022 published an article called Zero Trust in Zero Trust. He said that zero trust meant that a service needs to be trusted unconditionally and with certainty. Because of that, he also said that zero trust is unachievable in an enterprise network. Let that sink in for a second. Zero trust is unachievable. Well, why did he say that? He said that because, as he puts it, what zero trust monitors network devices continuously to help stop the inevitable penetrations early. Well, there are those two words again, continuous and inevitable. His view is that the malware developers have a distinct advantage over software developers. And that's in that the malware developers can understand what the principles are of the algorithms that are trying to protect our systems, whereas the programmers don't have any static malware to be able to check against. You remember the 560,000 malwares every day? There's no target to be able to aim at. The issue with zero trust, or the issue with really the software that is in this quadrant, is that software is logic, logic is math, math works the same for you as it does for me. Well, if I remembered my calculus, it might work the same for me, but you get my point. Because of that, software can always be hacked. And so the issue is, how do you deal with the inevitable penetrations of software? And the answer is, you just can't. You have to live with it. And that's not really the right answer. Going to the bottom right quadrant, this is where we see more sophisticated software like AI, metadata accumulators. There's going to stop more intrusions. It's going to cost more. Remember the 277 days and the 9.5 million in the IBM report that I told you about? The IBM report also goes on to say that if you had AI or more sophisticated software protecting your system, you could reduce the amount of time it takes to identify and contain a breach by about 108 days, and you could probably decrease the cost by about 1.7 million. So they admitted or told us that AI and these metadata accumulators are not solving cybersecurity. Yes, you're lessening the life cycle by about 40%, lessening cost by about 20%, even though there are a lot of other costs, people, time, efficiency, et cetera, that go into it. But you are not solving the problem. So where does that leave us? Where do we go? We go up into the top right quadrant. This is design focus, controlled behavior with a business focus. Hardware. The objective of this quadrant is to prohibit all intrusions and penetrations at a low maintenance and cost. Now, look, let's talk about maybe the one intrusion that we can't really stop at the moment. If somebody bribes an employee, takes their credentials, steals credentials, we can't protect you from yourself. But the objective of this quadrant ought to be to stop as many penetrations, breaches, intrusions as possible. So why hardware? Professor Frank Stagano's big stick principle, which I really like, whoever has physical access to the device is allowed to take it over. That means that most hardware is created with changeable or flashable memory, meaning that the engineer sits in their desk, his or her desk, and reaches out to the hardware out in the field and can make changes to it, which was great for the engineer because the engineer didn't have to then get in their truck or car and go over and deal with the hardware. But the problem is, if it works for the engineer, guess what? It works for the malware and the ransomware adversaries. And they use that and they can go in and change the hardware. So the first concept of our new old paradigm is let's create hardware that cannot be changed. Non-changeable, non-flashable memory. Once you do that, you control how things work. Your firmware can no longer be changed by a bad actor. Things are going to work the way you intend them to work. So once you have that controlled environment, let's see. We go back to our, once you have the controlled environment, what's the next step? Well, instead of identity that was in the bottom half of this, we're going to talk about behavior. And what does that mean? Well, every packet that comes into your network has to tell the hardware what it's going to do. Is it going to read, write, create, delete, insert? If it wants to read, well, okay. But if it wants to do any of those other things, that means it wants to change something in your system. Why should you ever let an unauthorized person enter your system and change anything? The answer is you really shouldn't. We're building a roadblock to continuous connectivity. So in this hardware that we're building that has non-flashable memory, so we control the environment, we would have a read port. And that read port would be where most of the traffic would go through, but only reads would get through. If anybody tried to come through that port with a command other than read, they'd be stopped. You'd have a read-write port where you'd have your handful of predetermined people who needed access to get in. That port would be controlled also by the firmware through a designated VPN, two-factor authentication. Even if somebody managed to find that IP address, they really couldn't do much with it. So you'd have non-flashable memory, you'd have a read-only port, you'd have a read-write port. How does this work? Well, for instance, it does really well for data protection or remote systems. For instance, financial information, HIPAA information, SCADA systems that control all of our critical infrastructure, ATMs, example, financial information. So you've got financial information in your company, lots of people need to see it, your CEO, handful of vice presidents, some of your salespeople, maybe even third parties external. They should be able to look at that data, but there is no way they should be able to change it. Whereas your CFO and your controller might be the only two who have access through the read-write port to be able to actually change that data. Say another example might be a well, that you've now connected that drilling rig to the internet so you don't have to drive a truck out there every day to monitor it. Well, lots of people need to monitor it and know what's going on. You'd stick one of this piece of hardware out on that well, lots of people would be able to monitor. Only those one or two engineers that need to get in to give it any instructions would actually be able to get through. You'd also want this hardware to be essentially plug and play. There's no reason to upset any ecosystem. You should still be able to use any of the firewalls or identity algorithms that you want to use for username, passwords, et cetera. You should not need to change any of the systems that it is protecting. Literally should just go in line in a plug and play concept. It would also be cool if it had a reporting function so that it would report back to the users to tell them who tried to come through the read port with any instruction other than read. That way you might even be able to figure out if somebody has penetrated your system and is trying to do something to the piece that you're trying to protect. Therefore, if we are going to try and stop inevitable penetrations from ransomware and malware actors, we've got to have specialized hardware.
I am inevitable. I
specialized hardware. So, look, I know this isn't supposed to be a sales speech, but by the same token, if you're breathing, you're selling. So here's a picture of our hardware, our patented hardware, that does everything that I just told you about. It has non-flashable memory. It cannot be changed remotely. It has a read port where most of the traffic goes through and allows reads to go through, but nobody can get through to scramble or change your data. It has a read-write port where the people who need to get in can get in and change things. It has a WAN port that allows for reporting, and it even has a fourth IP port, which is the port that connects over to whatever it is you're trying to protect. It's secure. There is no inevitability here. It works. Our systems are running on it. We'd love to talk more to anybody who is interested. In that vein, my co-founder, Vic Friday, who's sitting up here in the front, and me, we're both here for the conference. We'd love to talk to anybody about it. We really appreciate it. I'm going to leave you with these final last thoughts that I've cribbed from Tommy Lee Jones talking to Will Smith in Men in Black. 1,500 years ago, people knew that the Earth was the center of the universe. 500 years ago, people knew that the Earth was flat. 20 minutes ago, you knew that software was the solution to cybersecurity. Imagine what you'll know tomorrow. Thank you very much.
One more time for David Ronn.